All right. Check, check, check. We're in. Okay. So our warm-up is: a friend of yours solves for the missing sides of the following right triangles. Do you believe she did them correctly? Why or why not? And what advice would you give her? So those of you at home, you might want to pause and take a look at that. But those of us who are here, guys, so we're saying that she did one of these correctly. Which one did she do correctly? And let's see if I can get a little bit of help from empty seats. There we go. Alon, which one did she do correctly? She got the first one right. Great. So she did the first one correctly, so she needs to keep doing what she's doing on there. So that means she got the second one wrong. Charlie, were you able to figure out what went wrong on that second one? Okay, so what are some things that might go wrong, do you think, Charlie? What's something that she might have done? She might not have squared them. I mean, that's a possibility. So let's see here. So that would make it 17 plus 7. So 17 plus 7 is 24. And if we take the square root of 24... No, that doesn't seem to be it. That doesn't seem to be it. What do you think, James? Okay. Mm-hmm. And she got plus 7 squared equals that, and then she squared that, so she got the wrong one, mixed up the... that is what she did. Yes, exactly so. So she... Did she do that also? She also rounded it wrong. Look at that. Elisa's like, look, first of all, you're wrong, and even if you were right, you're still wrong. So, yeah. I think that's exactly what she did. Now, Caroline, why is that incorrect? Why is that wrong? Yes. We want to know if the area of this square is 17 squared and the area of this square is 7 squared, what plus 7 squared is going to give us 17 squared, and that's 240. We take the square root of 240. The square root of 240, yeah, but sure isn't that. 4 root 15, which is exactly 15.492. How many of us got that was about 15.492 there? Excellent. Very good. Well, you guys open up your planners to page 101. Happy National High Five Day. Yay! Yeah, hit someone nearby, guys. Go for it. Hey! All right. You guys got some weird high fives out there. All right, so... Let's see here. Can I get you in 5, 4, 3, 2, 1? Did you guys know that 101 is the only prime number with alternating 1s and 0s? So, like, 1's not prime because it's neither composite nor prime. 10's not prime because 10 isn't prime. 101 is prime. 1010 isn't prime. 10101, that's also not prime. I don't think so. Yep, that one's divisible by 3. 101, 010, that's not prime. 1010101 is also not prime. It turns out, guys, the reason that one's not prime is a little bit tricky, but someone has actually proved that no matter what you do, if you see a number like this, yeah, if you see that, you can be like, that's not prime. I don't know what it's divisible by. Did I miss? Oh, I did mess up. Oh, well. Yeah, exactly. You can't, if it's not a whole number, it's neither prime nor composite. It has to be an integer. All right, excellent. What is our first essential question? And I would love to get that from Chloe. What's our first essential question today? Awesome. What is the converse of the Pythagorean theorem? And how can I tell if it is acute? Well, how can I use it to, excuse me, if it is acute? Oh, did I really? If a triangle is acute, obtuse, or right. There's a whole lot of ways I could have done that right. I went for none of them, clearly. This bean, harvested while still in its pod, has been called French beans, Ericots verts, and string beans, but is usually sold under this colorful name, and those are green beans, yes. And in the medieval, that's a prince. A prince is correct. Hey! Okay, let's see here, guys. Underneath your warm-up, got a pencil? So, today we're going to talk about the converse of the Pythagorean theorem. So there's a kind of statement we make that's like an if-then statement, right? So if this is true, then this is true. And if we make that kind of a statement, we can actually start talking about other ways to restate it that may or may not be true. For example, I'm going to make this statement. In fact, here we go. Let's write this down. Statement. If it is a shark, then it is a fish. Would you guys say that that is true or that is false? I would say that's what? Everyone would say that is? That is true. If you have an animal that is a shark, then you know for certain that it is a fish, because a shark is a certain kind of fish. Now, there are different ways to state this. It turns out that statements have inverses, converses, and contrapositives. So let's start with the inverse. We're going to take the inverse of that statement. We're going to take the inverse of that statement, and then we're going to see if it's true. So the inverse of a statement is, if instead of saying if this, then that, you say if not this, then not that. So for example, this would be instead of if it is a shark, we would say if it isn't a shark, then it's not a fish. Is that true or false? Thumbs up, true. Thumbs down, false. Yeah, that's false. Can someone explain why that's false? Let's see here if I can get a little help. Elisa, why is that false? Sure, like what? Clownfish are most certainly fish, but they are not sharks. There's also a converse to this statement. So converse is curious, guys. So inverse means is if not this, then not that. Instead, the converse means instead of if this, then that, it's if that, then this. You switch the clauses. So can someone state the converse of if it is a shark, then it is a fish? If we switch those clauses, what do you think that's going to sound like, Chloe? Yes, so we're going to write that down. If it is a fish, then it is a shark. Is that true or is that false? Thumbs up, true. Thumbs down, false. Yeah, it's false for the same reason, right? There are examples of things that are fish that are not sharks. For example, catfish. Right, blobfish. Nemo again. Now, here's an interesting one. The contrapositive. Well, you do now, though. You do now, right? That's the point. That's why I'm telling you. The contrapositive is the inverse of the converse. Will you guys talk to each other? What would the inverse of the converse of if it is a shark, then it is a fish be? And is that statement true? Teach, teach! I think that's seals. Was there a question? Ah. Well, hold on. Let's see what we got here. All right, here we go. Jasper, what do you think? What would the contrapositive of that statement be? Yeah, if it isn't a fish. That says isn't, if that isn't a fish. If it isn't a fish, then it isn't a shark. Is that true or is that false, Jasper? Yeah, that is true. If you're looking at something that's not a fish, like a porcupine, that's not a shark, right? Like, that sounds like something like my 2-year-old would say. Like, he'd look at a porcupine and be like, shark! And I'd be like, I don't know about that, buddy. So the point is this, guys. Statements, if they're true, what's interesting is their contrapositive is always true. If their inverse is true, then their converse is also true. So what kind of statements are very interesting are when a statement is true and its inverse is true. For example, if Mr. Petersen is your teacher, now that's hard. Let's just get to we'll get to the Pythagorean one. Okay. Let's restate the Pythagorean theorem as an if-then statement. Got a pencil? If a triangle is right, then the area of the squares on its legs is zoom tight. Add up to the area of the squares of the square on its hypotenuse. That's the Pythagorean theorem, and it is true. The Pythagorean theorem is true. We can prove it. Now, it turns out that the converse of the Pythagorean theorem is also true. So will you guys talk to each other? What is the converse of this, and why is that interesting? Will you guys talk to each other? What's the converse of the Pythagorean theorem, and why is that interesting? Teach, teach! Chad, that was the inverse. That was the inverse. Converse. The converse is also, the inverse, converse, and contrapositive are all true. Okay. Can I get you in 5, 4, 3, 2, 1? So Chad accidentally said the inverse instead of the converse, but let's say that because the inverse is true. What is the inverse of this, Chad? Yeah, and since right triangles are the only ones with legs and a hypotenuse, you actually have to rephrase it. If a triangle is not right, then the area of the squares on its two shortest sides do not add up to the area of the square on its longest side. Because as Charlie was pointing out yesterday, the hypotenuse has to be the longest side of a right triangle. That's perfect. And that is true, which is also interesting, right? But what's the converse, Lucy? What would the converse be of this? It's okay, check it out. Watch this. Change this then into an if. Oh, so that's this guy. How about this guy? So you see this then? Start from here and change that to an if. Yeah, very good. Again, we have to rephrase that a little differently, though, because if we're looking at a triangle, it doesn't have legs if it's not a right triangle. It doesn't have a hypotenuse if it's not right. So we have to rephrase it a little differently. Got a pencil? The converse of the Pythagorean theorem. States oops. Come back to me. There we go. If the area of the squares on the two shorter sides of a triangle add up to the area of the square on its longest side, then it is a right triangle. Okay. Let's look at this as an example, okay? Draw a triangle. I've been asked before, is that a right triangle? Yes or no? Well, I don't know. Does it look right? Kinda. But guys, am I a perfect artist? So you can't just go by the picture, which is why we're going to go by the measurements. I'm going to tell you this is 91 feet. This is 60 feet. And this is 109 feet. Will you guys talk to each other? Is this a right triangle? Find out if this is a right triangle using the converse of the Pythagorean theorem. Teach! Teach! So that's 18,000, right? Oops. Oh, no, you're right. 3,600, right? No, well, yeah. Okay. Can I get you guys back up here in 5, 4, 3, 2, 1? James, is that a right triangle? How do you know? You took the square root of it, and you got 109. Very good. You could have also done 109 squared and seen that that was also 11,881. Either way works, but I'll tell you right now, the way that you did it, James, is going to help us out a ton. So this is right. Boop. Let's do another one. Let's try this one. Hey, I'm no artist. This is 20 meters. This is 11 meters. And this is 13.5 meters. Is this triangle right? Yes or no? Teach! Zoom tight. That triangle is not right. That's not right. Yeah. Oh, here, let me come. Let me see. Sure, so start with the square root. So hit the square root. And then just type that part, like that, whatever squared plus whatever squared in there. And then you can just do it all at once if that's what you're asking. As long as it's under the root, you should be good. Okay, can I get you guys back in 5, 4, 3, 2, 1? You guys are doing awesome. I think you guys way deserve a point. Thank you so much. All right, Jai, is that a right triangle? It most certainly is not. How do you know? Yup, you get 17.414. Put your pencils down for a second. I want to tell you guys something. Let me see what happened. We'll see what happened. Did we get about 17.414 for this, guys? Okay, I'll come see what happened. I'll tell you right now, guys, I'm looking at this, and for what it's worth, in 8th grade, the only thing they're expecting you to do is to be able to say that's not a right triangle. But it's so easy to go the next step, I would rather talk about that. I can tell you that that triangle is obtuse. I guarantee it is obtuse. Can you guys talk to each other? How do you know, based on, I'm telling you, all the information's right here on the screen. 13.5, 11, 20, and would I square those and take the square root, I get 17.414. How can I look at this information and say, that's an obtuse triangle? Teach, teach. You got it. Sure. This, well, I was going to save the square root of the answer on there. Okay. Can I get you back up here in 5, 4, 3, 2, 1? Let's see here. Can someone tell me how I know for a fact that those are obtuse? And by the way, I've got this guy, so you know this one? Whoops. Louisiana, we've done this one? All right, I'm going down because I'm on down. Dang old tubes trying to. Come on now, let's see what's going to Chad now. How we going to do it? I'm going to dang old tubes down and go. Yeah, exactly, man. So we're not going to give you no dang old right triangle. Going to be like coming like this, huh, now? Going to be like, no, we're going to 11 now. See what's going to be good now. Oh, that's going to be real long now. Let's do 0.11 now. Not too small. Okay, hang on. We'll zoom way in now. Come on. Okay. We're going to set that rotate in now. So it's going to be 0.11 right out on now. And this guy going to be now like 0.135 now. Going to be like, oh, and watch, this guy going to be right about 0.17 now, right? About 0.17 now. So, but that's not 0.17, that's about 0.2 now. Going to be like this now. Going to be like 0.2, which means in order to make this match, what this angle going to do? He going to wide up or he going to narrow out now? He going to dang on wide up now. He's going to be more than 90 now. So this is going to be now dang on obtuse triangle. We got this little guy, little baby triangle now. Come on, daddy. Oh, come on, daddy. Come on. All right, this triangle over here now, he obtuse. He obtuse. That's more than 90 degrees, right? Because you got now over there, we're going to get a right angle. But now, since the hypotenuse that I got is too long, he's going to be widening up that angle some, okay? Cool. How many of us feel like we understand it? It's no problem over here? Nice. Good job, everybody. All right, so here we go. Let's get another one down off the hook now. Okay. Ooh, this is going to be a nice one for you. All right, here we go. All right, here we go. I like this one. Okay. Oh, that's going to be too thin to see now. Come on. So we're going to change the color up here. All right, going to this purple. After the original, Louisiana basketball team. Now, you guys know what the original Louisiana basketball team used to be called right now? Because now they're the Pelicans. Yeah, it's the Jazz now. That's the Jazz. The Jazz used to be from New Orleans, man, because that name actually made some sense. All right. So here we go. They're going to be now 11 feet. And it's going to be now 13 feet. And I regret to inform you that this guy right now is going to be now 38, square root of 38 feet now. No, the square root of 38 feet now, not 38 feet now, the square root of 38 feet now. Y'all going to talk about this? What is now going to be, is this going to be now a right triangle, going to be now a cube, going to be now obtuse? What are you going to do? Go and talk to each other. I'm going to hear him go now, man, so I'm going to teach now. All right now, here we go. Yeah, this ain't drawn to scale now, is it? Nope, sure ain't. I did that on purpose now. Or so I would leave you to believe. All right, y'all, let's get y'all back up in here in 5, 4, 3, 2, 1. Let's see if I'll get now a little bit of help now. Let's see here. I'm going to go for Emmeline. Is this going to be now an acute triangle obtuse, or you think it's going to be right now? You didn't finish? Tell me what y'all was up to there. Yeah. You know, I would just be 38 now, and I want y'all to notice this ain't drawn to scale now, and I did that on purpose now. That if this was drawn to scale, it should have been flipped, because the square root of 38 is actually shorter than 11, yeah? So now this has a smaller area than this guy, but that's okay. These don't got to be drawn to scale. That's all right. Go ahead, Emmeline. What you got now? $121 plus 38 now. Okay, I got 159. Excellent. So then you're going to go down 13 squared, and then you're going to say 169. Perfect. Now, so here's the question I got for you. We know it's not right because the area on these squares don't add up to the area on this square. But do I know if that's acute or that's going to be obtuse now? How come? Well, let's see here. Why don't we take it to the next step now? If we did the square root of 159, the square root of 159, thank you, calculator, about 12.61, right? About 12.61 now. So if this was a right triangle, this would be 12.61 feet. Now, is that too short or is that too, yeah. So if this was right, it would look something like this. But since it's too long, 13 is too long, what's going to happen to these legs here? They're going to widen, actually, right? Since I want the hypotenuse to be 12 point something, but he actually 13, he's going to widen out a little bit. It's kind of the opposite. It's kind of weird, right? Because we imagine what the hypotenuse we wish we had, and then we widen it out. And so we got this 13's too big. So he now this guy, I'm going to obtuse now, okay? I'm going to be able to get that guy now there. We're going to be obtuse now. Okay, perfect. Okay, here we go. Let's keep going now. Let's get this next one. Let's get this next one. You got a pencil now? All right, with extreme apologies. We're going to draw this guy now. We're going to draw this guy now. We're going to draw this guy now. You sure look right. This guy here gonna be 3 square roots of 5 This guy right here now going to be 5. And this guy right here now going to be 2 square roots of 5. Now, folks, a lot of people get in trouble here because they try to do 2 root 5 squared in their calculator, and he don't know how to do now. 2 square roots of 5 now. You don't do that, and you're going to square it. You're going to say that's 10, but that's wrong now. Yeah, you got to put it in parentheses, or if you prefer, you can just do 2 roots of 5 times 2 roots of 5. And so the area there going to be 20. And then 5 times 5, that's 25. Then over here, we're going to add them up now, 45. And then we take the square root of 45. Oh, hey, that's 3 square roots of 5 now. So is that a right triangle, acute triangle, or obtuse triangle? That's a right triangle. So we're all good now. We're all good right now. Okay, cool. Now, got a pencil? Let's say I got a triangle now. You're going to have these sides. I'm just going to write them out now. 4 square roots of 3. 3 square roots of 5. 5 square roots of 2. So imagine a triangle with those 3 sides now. Now, when I say teach, I want y'all to say, okay, we talk to each other. What is the number one problem with trying to start this problem? Look at your converse of the Pythagorean Theorem there. What is the problem with trying to do this thing? Bob, teach! And that'll be 5 minutes for the Louisianan. Can I get you in 5, 4, 3, 2, 1? Can someone tell me what the challenge is here? Why is this going to be challenging to start? Cormac. We don't know which one's the longest, right? We don't know which one's the longest, so we're going to have to find out. 4 square roots of 3, let's get that approximated. 6.928. 3 square roots of 5. 6.708. 5 square roots of 2. 7.07. So 5 square roots of 2 is going to be the longest side. So now we're going to see what 4 root 3 squared plus 3 root 5 squared is. 4 root 3 times 4 root 3, that's 48. 3 root 5 times 3 root 5, that's 45. So 48 plus 45, take the square root of those, and I definitely didn't get 5 root 2. I definitely didn't get 5 root 2. I got 9.643. Now, guys, that's the hypotenuse I want for it to be a right triangle. The long side I got was 7.071. So was the long side I got too short or too long? It was too... So this is... Okay, so this is the triangle I got. This one right here. Right? Where this was about, let's see here, 6.7, let's just make it really easy, 6.7, this one was about 6.9, and this one was about 7.1. Now, if it was a right triangle, I just figured out that if it was a right triangle, the hypotenuse would be 9.6. So if this was a right triangle, 9.6 would be here, 6.7, 6.9. Now, is 7.1 shorter than the 9.1? So that means that this thing actually shrunk. It shrunk. So what do these side lengths have to do to meet it? They also have to shrink, which it won't let me actually do. Which means what's going to happen to your right angle? It's going to become acute. So this was an acute triangle. There is a self-assessment on that, but you've got these last 5 minutes to yourselves. So you guys can put your calculators away, head back to your assigned seats. After this, you're going to go to Warrior Time or to your study hall or wherever. That's all.